conservation of energy in general, and there will be another one, which is number 3, the law of conservation of mechanical energy. And let me talk about it now. Let's start with the number 2. We said that in this problem, when we were pulling this under the effect of friction, we have here 2 non-conservative forces, and we have 1 conservative force. Which one was the conservative force? Here, gravity. In addition to this, there is Fn. Since friction is non-conservative, the force that we are doing, which is related to the friction somehow, why? The force cosine theta minus the friction equal to ma. So somehow my force has to be related to the friction in the formula. F cosine minus friction equal to ma. My force depends on the friction. Since my force depends on the friction, or will be related to the friction mathematically, is non-conservative as well. So we cannot have potential energy for this. The gravity is conservative, but the normal force, what is the work done by the normal force always? 0. It doesn't matter if it's conservative or non-conservative. What will be the work done by the normal force always? The work normal set perpendicular. And if the normal force is perpendicular, cosine of 90 degrees, how much will be? 0. So always will be 0. So the work done by the normal force always will be 0. It doesn't matter if it's conservative or non-conservative. The other 3, this is non-conservative, non-conservative, and conservative. So the net work according to this theorem have to be equal to the change in kinetic energy. But the net work is the summation of the work done by conservative plus the work done by the non-conservative. Is that correct? So we have here conservative force, the work done by this, plus this, plus this, plus this. At the end, we have the work done by 2 non-conservative force, right? And the work done by a conservative force. So the net work is the summation of both works. So if I move the conservative force to this side, WNC is equal to delta K plus WNC, plus WC. But what is WC in terms of potential energy? What did I say? How are they related? This is plus, I move to this side, is minus. How this and this, how the potential energy and the work done by the conservative force are related. What did I say? What is the work done by Fg? Negative mg delta y. What is the work done by the gravity? Sorry, what is the potential energy or change in potential energy due to the gravity? Mg delta y. How are they related? Opposite. So if this is opposite to negative delta u, then I can say that the work done by the non-conservative force has to be the summation of the change in kinetic energy plus the summation of change in potential energy. Can you see that? So since delta u is negative WC, this is right. And this is what we call the second law of conservation of energy. Meaning that if we add the change in kinetic energy of the system and the change in potential energy of the system, that will be the work done by the non-conservative force. Which in this case will be the work done by F plus the work done by friction. But what is delta K and what is delta U added? I can say that this will be delta K plus U. And what is the addition of kinetic and potential energy? How is called that? Mechanical energy. So WNC, by definition, will be the change in mechanical energy. So if there is any change in mechanical energy, that change where we go? Where goes? If there is a change in mechanical energy, where goes? To do work done, or will be the work done by the non-conservative force. Got it? So, in other words, look, I came at 5:40. I start teaching, right? I am moving from here to here, in addition that I am expending my internal energy. So there is a work done by me and the friction, right? Work done by the friction. At the end, I will have the same amount of joules that I enter here? No. So if I spend in friction here 20 joules and I came with 100 joules, the change in mechanical energy, which is kinetic, and all this will be, let's say I start at 100 initial. I finish at 80. Where went the 20 joules? Work done by a non-conservative force. And what is the work done by the non-conservative force? The work done by the friction. Got it? So, if there is a change in mechanical energy, that change has to be this. Now, mechanical energy final and mechanical energy initial. This is what we call the law of conservation of energy, which is the second. How is this different to this? Not much. I derive this from here. If I go to here, this is the work done by F. This is the work done by the friction. And this is the change in mechanical energy, which will be final minus E initial. But what is the meaning of E? What is E? No, yes, it's the kinetic, but also the potential. So the summation of all kinetic and all potential is what we call mechanical energy. So if we add the kinetic and potential energy at any point, will be the mechanical energy. So, for instance, let's say this is the mechanical energy. What is the mechanical energy at this point? Given by what? Kinetic or potential? Potential. When this is hitting the ground, just before hitting the ground, what type of energy will have? Kinetic. So the energy transforms from potential to kinetic, right? But if there is a resistance here, there will be energy spent due to the air resistance. That will be the work, the difference. If there is a difference, if this start here with 20 joules, this start with 20 joules, right? And finish not with 20 joules because some of the energy will be due to the air resistance gone. This, do you think that will be the same 20 joules going down? Can be the same 20 joules going down? No. So if this is 20 joules, this is the potential. This, at the end, due to the air resistance, will have only 15 joules. 5 joules are gone as air resistance, right? So this is an example of where we have, or where we apply this theorem. But if now, the third theorem, if there is no non-conservative force, which is this, the WNC is 0, which is this example. Let's say that here there is no air resistance. There is no non-conservative force. This will be 0, correct? So what will happen with this is the second theorem. What will, if this is 0, what will happen with delta E? Equals 0. So that the meaning of this is that what? EI is equal to E final. So EI is equal to E final. If there is a change in kinetic, that change in kinetic has to be compensated with what? Potential. With change in potential. So if the kinetic decrease, if the potential decrease, what will happen to the kinetic? Increase in the same way. This is this. And that is called law of conservation of mechanical energy. How are these different? When you read law of conservation of energy, any energy. So, if there is a change in mechanical, have to go and transform into another type of energy, which will be heat. Another energy, which is non-mechanical, is heat. So, the change in mechanical have to go as a heat to this. And this is what we call chain law of conservation of energy. This, if there is no non-conservative force, there is no heat generated. The change in energy in mechanical have to be equal